let me say just welcome to Christophe. Chris.
Yes, usually.
And he's from the School of Business of University of Leicester. With a background in economics, but with interest in physics. So, and in fact, the talk today is about physics and financial economics, just to see if this is a possible dialogue or something more possible. We are streaming also.
All right, so I will first of all, I will say hello to them, and then I will just pay attention, to be in the field. Okay, so thank you very much. Well, first of all, thanks again, Professor Mantegna, for giving me the opportunity to be here this morning with you. Actually, so I'm going to talk about economic physics and financial economics in a possible dialogue. Well, we were talking a bit before. I will not do physics or economic physics or finance this morning. I will use my background in philosophy of science because I have...
I didn't slide this, sorry.
Yeah, no, it's no problem. But
Cambridge student on philosophy of science.
Yeah, the point is that, yes, I have a background in finance, financial economics, but I'm finishing now the second PhD in philosophy of science, and the topic is economic physics in Cambridge. So that means that this is what I'm going to do here. I will, we are almost on holiday, so I will propose you to do a bit epistemology, so like a reflexive perspective on this possibility to combine finance and economic physics. So I'm aware that this switch is a bit general in the sense that I know that I will do some categorization here. It's a part of the game. When you want to talk about the knowledge, you have to make some categorization. So I know that you can say yes, but I know one work that it's not totally like that. I'm aware as well. I mean, you can share with me if you get on, but I mean that I'm aware that what I'm going to say is a bit general categorization, but I have to in order to be sure that we can talk about. So here, this is the menu. I'm going to talk about what I propose you is just to give you kind of reflexive perspective on economic physics first. I will talk about methodological diversification in economic physics. It's the fact that, well, you know what is economic physics. It's quite new field, but we can observe since 2005, a kind of diversification of the field in the sense that I'm going to talk about that, but we can observe that we have what we call statistical economic physics, what we call agent-based model economic physics, top-down agent-based economic physics, bottom-up agent-based economic physics. I mean, we have different kinds of economic physics. Today, economic physics it's a big literature, and a lot of works are related to economic physics. So I just want to give you a quick word about that. I'm not going to talk about that in details, but just very quickly. And then, even if we observe a diversification of the literature, what I would like to mention is the fact that there is a conceptual coherence, a very minimal one, but a conceptual coherence. And then I will then talk about economic physics as a Duhamian field. So this is the philosopher point of view. To some extent, I will just emphasize very quickly that economic physics can be seen as a Duhamian extension of physics to finance and economics. And finally, I will talk about finance as a naive Popperian field and how people in economics, we are used to, I say we because I teach finance, we are used to justify the models and how we develop knowledge. And finally, just a conclusion, like, is it possible to have a dialogue between these two fields? So, another point that I want to emphasize here, I'm going to talk more about financial economics. I know that economic physics is not dealing only with finance. I know that a lot of works are done on incomes or size of companies, on a lot of things. I'm aware about that, but here I'm going to talk about financial markets and what we call financial economics. So the characterization, the statistical characterization of the financial prices and returns and these kind of things. All right. So I will all the time talk about this comparison. Okay. So very quickly, economic physics. So you know what it is: a quantitative approach using ideas, models, conceptual and computational methods coming from statistical physics and applied to economics. It's not, well, we know that here, it's not a transfer or translation of physics concept in economics. That is the interesting point, because you know, a lot of people, when I give a talk with people in economics and finance, they said, oh, econophysics is nothing new. And they say, look, for example, Black, Fisher Black. This guy was physicist. So, and Black and Sports models, this is econophysics. So, econophysics is nothing new. Yes and no. Yes, regarding to the influence of physics to finance and economics, on finance and economics. But not in the way of doing that, in the sense that what Fisher tried to do is to integrate some concepts and models coming from physics, but integrate in the mainstream, in the knowledge mainstream. Because if you check what they did in Black and Sports models, actually they wanted to apply the capital asset pricing model to warrant. And actually they were not able to extend to the model, the Black and Scholes model. And then the knowledge of Black was useful in order to compensate and to solve the problem, the conceptual problem they had. Because at the beginning they wanted to do the capital asset pricing model, to apply the capital, the CAP and the CAPM. And actually that's very funny to see that it's possible conceptually to make the link between the CAPM and the Black and Scholes models. I mean, mathematically there is a strong link. So what I mean is that what Fisher Black did is just to extend the mainstream knowledge in finance. He didn't came with something, he came with something new, but he extended the mainstream knowledge. And this is not necessarily what people do in econophysics. But econophysicists, they will say that we will apply this, and this is what we can say about it. But people in finance will say, yeah, but we don't do that. So it's a bit different. So this is why I think it's important to mention this difference. The importance of instability versus equilibrium in economics. So, you know, in finance, for example, all the time we talk about this equilibrium, arbitrage pricing model or capital asset pricing model. All the time the concept of equilibrium is very important. It's not necessarily true in econophysics, as we know. Data-driven model in econophysics focused on data, and it's not necessarily true in economics and financial economics, where there is a kind of axiomatic perspective, we have an a priori, and then we try to implement this a priori through the data by using statistical tools, and we try to have a statistical significance in order to justify this a priori, but it's not necessarily true with econophysicists. They don't come with this kind of axiomatic perspective. I will give you more words in a few minutes on that. And finally, yeah, the fact that financial markets can be considered as complex systems with emergent properties, scale invariance, and all these properties that are usually associated with a complex system. So again, you might have another definition of econophysics. I'm not saying that here you have a, you know, all key aspect of econophysics. I'm just telling you that here this is very roughly speaking what we can say right now.
Sorry, can I ask if you can higher the voice a little bit higher?
Oh yeah, sure. Sorry about it. Yeah, sure, of course. I will.
The room is not very.
The acoustic
It's very close.
No problem. No problem.
But finally, it should be also.
Yeah, sure. Of course.
And sorry.
No. You did well to ask that. I hope, I mean, if I talk a bit louder like this, it's okay for you now. So, well, very quickly, I mentioned before this methodological diversification of econophysics. This is based on a paper. Recently, they did a special issue about econophysics. And this is based on this special issue. I think Tiziana Di Matteo was editor for this journal. And actually, this is the three categories of econophysics that I identify in this paper. And from a methodological point of view, I'm not talking about the topic itself, I'm talking about the methodology these physicists are using. So first of all, statistical econophysics. So by statistical econophysics, I mean the original econophysics. So that means the one developed by Professor Mantegna, by Professor Stanley, all this statistical approach dealing with macro statistical patterns, identification of macro statistical patterns and these kind of things. So I'm going to talk about that in a few minutes. I will not develop further these two other aspects, but bottom-up agent-based econophysics aims at reproducing macro-evolution of economic financial system by starting from micro-interaction. So it's just a classical agent-based modeling, but it's a bottom-up approach, starting from the micro perspective, and then you have the top-down agent-based econophysics that is very recent. We don't find a lot of articles on that. But they try to reproduce macroevolution of system by starting from micro-interaction. Was calibration depend on parameters observed at macro level? This is the difference with the previous one. I will give you, this one, confusion between the two computers. Statistical econophysics. This is the one I'm going to talk about in this presentation. So this econophysics, again, this is a category here, because it's a very broad, very general definition, okay? Focus on the macro results of complex systems whose complexity is assumed to be statistically captured through analysis of large sample of data. So what does it mean? That means that, okay, we have a huge amount of data, and what we try to see is to see to what extent we can identify so macro regularities by assuming that, the reasoning is like, okay, we have a kind of infinite numbers of data. If we would have an infinite number of data, that would be better, because then we would be like more confident about the conclusion that we could draw from the analysis. So it's a kind of asymptotic reasoning here that they use. And they, of course, all interactions between all single elements are considered as too complex to be individually captured. So just focus on the macro perspective. You know this perspective already. So this is the kind of, you know the power law and this kind of macro statistical patterns that statistical econophysicists are trying to identify. Professor Montaigne did a lot of work on that, of course, so you know that. Very quickly, the bottom-up adjunct-based econophysics. This is a, I'm not very good in drawing, and I'm a very bad artist, so it's just very quickly something that I try to kind of visual summary that I try to do with a lot of disadvantages, but at least just to have a visual picture. So what they try to do is bottom-up adjunct-based econophysics. So it's a classical adjunct-based modeling. Basically, what they try to do, step one, is to define infer plausible physical interactions, micro-needs. So they try at a specific moment to define specific micro-interactions, that is, these interactions would be physically plausible. Physically plausible, what does it mean? That means that makes sense for a physicist, but not necessarily for an economist or for a philosopher or for somebody else. But that makes sense for a physicist to consider that we have this kind of interaction at this micro level. This is what I mean here. Then simulation, you know how adjunct-based modeling works, so a lot of simulations. Then observe a kind of emergent order, and then extend the results, and to say that these results can be extended to economic financial systems or physical systems. So an example, this I could have mentioned a lot of articles. You have recently you have a very interesting book, adjunct-based econophysics, that has been published recently. I forgot the name, Christelli, I think. I don't remember his name actually. Anyway, I can give you the reference if you want, but there are a lot of examples, and this one is just like, okay, these two guys, they try to explain income tax evasion dynamics can be modeled through an adjunct-based econophysics, and they use micro interaction by using the Ising model. So that means that what they define at the micro level makes sense if you are a physicist, because you know this model, you know what does it mean to have the spin in this direction or the other direction. But maybe an economist would say, what does it mean, a spin, by the way? What does it mean, this? So this is what I mean by physically plausible here. Important because adjunct-based modeling is nothing new from an economic point of view. In economics, they use that as well, but they use economic interaction. They will say, oh, the maximization of the return, or or they would like to maximize the utility, or this guy would like to increase the return, or whatever. But something that makes more sense from an economic point of view. But the methodology by itself is nothing new or nothing different from what economists are doing. That's interesting because that means that they are implementing the same kind of methodology on the same kind of data, financial markets, for example, but they do that in different way, so they can draw different conclusions. So that's also the reason for why I wanted to work on this kind of topic, is why two communities that are extremely clever, they have a lot of techniques, they are dealing with the same kind of data, with the same reality, but they are not able to talk together. most of the time. And they have also different results. So why? That's interesting from an epistemological point of view. That's why I'm here trying to understand what this one are doing, what this one are doing. And that's why, again, what I'm here, I'm not talking about this work specifically, this model or this model, I'm talking in terms of category. Two communities, they have different way of thinking, and this is what I'm trying to do here. So, agent-based modeling, economists are using that, physicists are using that, but in different way. So this is what I want to emphasize. Top-down agent-based econophysics. I'm not sure that this picture is the best in the world, but it was not easy to give a summary about this. Because it's interesting. Because I didn't find a lot of works on that, but you can find, this one is probably the best, I mean, the more characteristic, the telling example, is the fact that what they do here, what is different, is the fact that they will not start, the first step will not be necessarily the micro-interaction. They will first look the evolution of the system. They will try to have a statistical information, like statistical econophysicists, like a power law or whatever. They will try to have a statistical information from which they will try to infer, deduce, or create a micro-interaction. So that means the micro-interaction will not come. Identification of macro-pattern from the system, then they infer some statistical constraint at the micro level. So that means that it's not necessarily the same, because before, if you remember, when we were talking about this one, we start here from, okay, what would be physically plausible, what kind of physically plausible interaction we could have. If we take Ising models, they could act like this or like this. But they don't start with the macro perspective. They start straightforward with the micro. But here, they try to say, yes, but we should not start with the micro. We will start with the macro. We will try to see how things are moving. We will try to see a statistical pattern, then to infer, to deduce something that would make sense. That could be if we have, for example, you know, if it is a scaling, if we are in a scaling system, it could be something regarding to stability of the system, that something that is true at the macro level could be true at the micro level. So, you know, they could use these scaling properties in order to infer something at the micro level, in order to define some plausible micro interactions. The plausible here is related to what they are able to deduce from the statistical observation of the system. And then, same game than usual in agent-based modeling, simulations, we have an emerging pattern that we try to compare with the system. So it's not common, but it's quite new, because to be honest, I didn't see, I mean, as far as I know, we don't use that in economics. In economics, we are very micro-oriented in methodology. So this is specific. As far as I know, to my knowledge, maybe you have you know something in economics. I would be very happy to share with you then. But as far as I know, I didn't find articles in economics or financial economics where they are implementing this kind of category, this kind of work. This is something that econophysicists, it's a contribution from a methodological point of view of econophysics to the way of characterizing the financial dynamics, according to me. So, but that's interesting. I will not talk more here. I mean, in the paper that I mentioned, I can send you if you want. I give a bit more, you know, methodological aspect and examples of articles in the literature, but here I will not talk about that. I will come back on statistical econophysics, so just the macro perspective approach. However, I would like to emphasize the coherence of econophysics, because even if we have a diversification of methods, I have the feeling that econophysics keep a coherence, a conceptual coherence. Well, a very minimal one, of course, but this is always what philosophers do when they have to define a hardcore of a specific field. They focus on the minimal aspect in order to say something, because if we don't focus on the minimal aspect, we cannot say something else. So here, what is common to all these methodologies? The fact that they work on financial economic phenomena, fair enough. The fact that the explanandum is what we have to explain, is the emerging property. Something that will happen on this phenomena must be captured, must be explained. So this is what has to be explained. So emergent properties. could be a specific law, it could be specific behavior, if we talk about tax evasion, and it could be something, but something emerging from the system is there, must be explained. And explainance, that means how to explain. By using an asymptotic reasoning, that means that the more data you have, the better it is, roughly speaking. Okay, so this is what is common to all of the methodology. And basically, this conceptual coherence can be presented as a kind of asymptotic reasoning. Again, as I told you, they try to explain something is happening there. Something, I mean, all of these methodologies, they try to explain what's happening on economic financial systems. And the more data they have, the better it is. And then they have a kind of asymptotic reasoning in which large number of implementations is useful. So you have kind of a limit. I mean, it's kind of, this is a classical asymptotic reasoning, where you have like a macro perspective T1 where you use a specific micro theory T2 if the law of T1 can be asymptotically derived from the observation iteration of T2. So to some extent, they have a specific system, they have data, a number of data, that if the more data you have, the better it is, in order to find a specific macro perspective or emerging order or whatever, and then depending on the methodology you will have the link, the reduction with T2. I will not explain that in detail here, but if you have a bottom-up agent-based modeling, it's a specific link between T1 and T2. If you have a top-down agent-based modeling, it's a specific reduction between T1 and T2. If you have statistical econophysics, it's another one. But at least we could say that they use, all of them are using this kind of asymptotic reasoning, but the reduction, that is a very important topic in physics and also in philosophy of science, is a bit different depending on the methodology. So, statistical econophysics. So, as I told you, I will not talk more about agent-based modeling here. Now I'm focusing on the original econophysics. Why? Because, well, if you check the literature, this is the oldest econophysics, and this is also a lot of articles regarding to that, because it is the oldest. So it's easy to find a lot of data, a lot of articles, so it's easier for me to go through this literature and to try to identify some categories, methodological categories. And what I try to do is the fact that, okay, what they do in statistical econophysics, they try to identify macro patterns through this asymptotic reasoning, this idea that the more data we have, the better it is in order to capture the essence of the phenomenon. And so doing, it's a kind of what philosophers call a minimalist idealization, because in philosophy of science, an asymptotic reasoning is a minimal model. Why? Because you focus only on what is important. So that means that it's a model based on a asymptotic method, exhibiting a universal pattern from which adding more details to the minimal idealization would not improve the understanding of the target even. Ising model is also a minimalist model. You know, it's a very easy model, but you don't need more in order to characterize the phenomenon. If you put more and more details, you will not have more information about the essence of what's happening there. So it's a minimal model. And by using this kind of asymptotic model, it used to be a minimalist model. So that means that statistical econophysicists, by using asymptotic reasoning, are implementing what philosophers call a minimalist idealization. And this link between asymptotic reasoning and minimalist idealization there are a huge literature in philosophy of science regarding to that, and maybe you heard about that as well in physics. So if we come back on this asymptotic reasoning in statistical econophysics, there are here if I use this, this asymptotic reasoning, I told you that n is the number of observations, T1 is the statistical macro pattern, so that means that what will emerge, what you will observe at the end, the number of observations, the more you have, the better it is. It's a phenomenology, from a phenomenological point of view, you will have the emergence of T1, but T2 refers to an undefined characterization of the low level, microscopic complexity, whirling individual level. And actually, you don't have to define that clearly. from a statistical econophysics point of view. That means that we focus only on on the macro level, because the micro level is too complex. So the way statistical econophysicists are implementing this asymptotic reasoning is this one, roughly speaking. So they focus on T1, we know this. T2 is something that we know it exists, because physicists, they know something is happening at the micro level. They know, they don't deny that, sorry. But they say it's not important here. It's not the point. So this is the way they will implement this reasoning. If we are talking about agent-based econophysics, it's different, the way of implementing this asymptotic reasoning. But at least I have the feeling, and this is what I explained in this paper, that all of them are using this kind of very simple asymptotic reasoning that could be used as a categorization of the way of thinking, if you want. So that's how things are going here. And before talking about that, is the fact that this asymptotic reasoning, again, is not my claim by saying that an asymptotic reasoning is a minimalist idealization. It's a minimalist way of talking about the world, because we focus only on what is important. T1, we observe something, we have to characterize it, that's all. Yeah, but you know, what's happening about this? What about if the color of the room is different? We don't care. This is something into T2, but it's not really important. It's the same with Ising model. If you change a little bit something, or if you want to know in detail the contextual element, it's not really important about the characterization of the magnetization of the phenomenon. So it's the same. So that means that statistical econophysics, you got the point, I hope. For me, statistical econophysicists, they are using an asymptotic reasoning in a specific way that I've just explained before. Okay, fair enough. So doing, they are doing a kind of analogy with, they are doing analogy between physics and economic financial systems. They say, okay, we have knowledge, and we would like to apply that outside of our disciplinary context. So doing, they will focus on similarities between the two systems. So what kind of similarities? Here on this table, I just put some non-similarities and observational similarities. So we know that in both sides, in physics and in economics, we talk about interacting elements system. So that means all systems are based on, are composed by interacting elements. We know that. Okay, fair enough. High number of micro components. On the other side, high number of individual agents. Okay, that makes sense to say that it's the same. Complex micro interaction in both sides. Complex micro behavior. Okay, that makes sense to make the link here. So observational similarities, that means that we can observe it, but we cannot necessarily explain it at first sight. It's not intuitively easy to guess. That, like a power law, I know that statistical econophysics is more than just power law. I'm talking here about power law because it's a telling example of statistical econophysics, and probably also the more, if you check the literature, is the more often quoted example. So I continue this example here. Okay, so I know that it's more than power law, but let's continue here with power law idea, because it's a telling example of what is statistical econophysics. So dynamics following a power law, dynamics following a power law. It's an observation. Okay. So what is interesting is the kind of, it's a kind of analogy, because I'm talking about analogy here. And in philosophy of science, when we talk about analogy, we have to define analogy. We have to study analogy by decomposing into three aspects: positive analogy, negative analogy, and neutral analogy. And it's important to have the three aspects. If not, that means something is wrong in the analogy, because it's impossible to have the perfect analogy does not exist. So that's why, basically. So here you have physical system and economic system. Interacting element, I mentioned that. So here I mentioned the positive analogy means what we know is common, or what we can consider that it is common. That you are not shocked by reading that we can say that the micro interaction and the micro behavior could be associated. So this is what we mean by positive analogy. It's impossible to have the perfect analogy, because the perfect analogy would mean that you have only positive analogy. So that means it's not an analogy anymore, it's the same case. I mean, we are talking about the same category of phenomena. It's not an analogy. A real analogy is when you have negative analogy. Negative analogy is what is different. What is different is the fact that non-human micro-entities and human agent. Here I did it quickly, but by human agent that means a lot of things, of course. That means psychology, that means sociology, that means a lot of things. So very quickly here, we should have some small stuff here. But it's a negative analogy because we know it's not the same. We know that particles are not human beings. So we have to take into account the neutral analogy. Now, this is the most interesting aspect when we talk about analogy. The neutral analogy is normally what we learn from the association between the two systems. What we learn that we didn't know before. This is the neutral analogy. That's why it's neutral. It's because we didn't know that before. And when we put them together, physical system and financial system, when we put them together, we can see something in common that we ignored before. This is the neutral analogy. And this neutral analogy must be based on a kind of plausibility. In physics system, when you have this, if we continue this example with the idea of power law, and that we can associate a kind of macro patterns with this kind of complex system, we can infer, not really deduce, we could induce, it's induction to some extent. We can induce or infer the fact that if we observe the same kind of characteristics for complex system, we can induce, through the positive negative analogy, we can induce that we have a plausibility because we observe also the same kind of macro patterns. So where you can make the link between financial economics and physics as disciplinary area of knowledge is to work on this plausibility. Plausibility, what does it mean for physicists and for economists? It's not the same, as you can guess. Because physicists will say, we know what this plausibility, what does it mean, because we have all our theoretical frameworks to explain in physics why we can have this kind of macro statistical pattern. It's related to this, and this. And then, you know, it could be self-criticality, whatever. I mean, they have something to explain. But when they go in economics, then they have everything is coherent from an analogical perspective, and from their point of view, it's logical. But from an economic point of view, they will say, what is the plausibility? This is the key point. And I'm going to talk about that in a few minutes. The plausibility is not necessarily the same. But from an economic physicist point of view, it is. That makes sense, and it is coherent. So this way of using analogy, I mean, here I don't want to look a bit schizophrenic, but it's not necessarily easy because I have to try to use the perspective of econophysicists, the perspective of philosopher of science, and the perspective of an economist. So if I look this from an econophysicist point of view, that makes sense. It's coherent, and this plausibility can be explained with some theoretical framework that physicists have, and that makes sense. Fair enough. If I take the hat of philosopher of science, and then I will just check the component of this. It's just a summary here. But I explain that much more in the PhD. It's logical. That makes sense to do what they are doing because they have a specific disciplinary definition of plausibility, and that makes sense. If we are economists, they don't really like this, and they will not agree with that because they will not see the same thing, even if they have the same data. They will not see the same thing. That's another interesting point. Why? Two communities, two scientists, they will not see the same thing in the same sample of data. Because they will not look in the same way. That's all. But that means that's interesting. So if I come back with the hat of the philosopher of science, this way of implementing analogy outside of physics is totally in line with what Pierre Duhem, emphasized and promoted in the past. So the history, this is a quotation of Duhem here. So actually two quotations, but not another one from Schaffer. So this way of working, this way of using physics outside of physics in order to extend knowledge, to improve knowledge, is totally in line with what Pierre Duhem was emphasizing. So he was explaining that analogies between two distinct categories of phenomena, this is exactly the case between finance and physics, has perhaps been the surest and most fruitful method of all procedures put in play in the construction of physical theories. And it's interesting to read physical theories. It looks like it's from a physical point of view again. So it looks like if we read this again and again, it looks like you are a physicist. If you do this, if you go out, you will improve the knowledge in physics from a Duhem point of view. That's interesting. But it's not only in physics, it's also in finance. So that's the interesting point here. Everything, here I just put like one slide, but if we check in details a lot of works in econophysics, in statistical econophysics, we can really observe this Duhemian way of extending the analogy with a lot of implicits. We do that in physics, so we are sure that we can do it in finance. It's exactly what Duhem explained in his books. And an interesting aspect, I will make a kind of balance. If I use a bit the perspective, I would say that, yes, this Duhem, the construction of physics, then it's a kind of abolition of causal explanatory ambitions. Because what is the cause? What is the causality then in finance of this extension? We are not talking about causality anymore. We don't have to. There is no obligation. It's very old-fashioned. If we focus only on causality in science, it's very old-fashioned of doing science. We know that today science is not based only on causality. But, moreover, what is causality? If we begin to talk about that, we will be here until tomorrow. But at least we have to take that into account. It's a specific way of doing science. It's a specific way of extending physics. So that's interesting, because then it's more on descriptive function. And this is why I wanted to put that for specific work. Abolition of causal explanatory ambitions, descriptive function. I wanted also to emphasize this, restricted to purely internal context of justification. What does it mean? This, if we read it again and again, it's interesting. That means that we know that we are in a science that is not based on causality anymore. First point is phenomenologically descriptive. Okay, it's not a big problem by per se, but we are in that kind of science. And internal context of justification. That means that why that makes sense to do that, because this plausibility is internally explained in physics, but not from a financial point of view. And that's why you can have sometimes a lack of dialogue with physicists, with people in finance. Because they will say, I disagree with what they say. First of all, I don't see the same, and how they explain that makes no sense for me. What is spin? What is magnetization? I don't understand. So it's a bit quick, but it's like that. So that's interesting. These two quotations are very interesting, I think. And this one, we were talking about that, but this morning, but this quotation is a good example that it's a kind of epistemological justification in order to extend physics outside of physics in order to come back in physics to improve physics. And Duhem was proposing reflections on that by using analogy, and econophysics is a good example of that. And that's interesting, because usually physicists, when at the period of Duhem, it was between physics and other hard science, let's say, but not between physics and economy or finance or something like that. So this is from an epistemological point of view, a philosophical point of view. That's extremely interesting, this point. So anyway, I think you got the point. Okay, so I hope it's clear for this Duhemian way of extending physics outside of physics. Now I'm going to talk about financial economics quickly.
Was Duhem giving some example?
He gave some example, but he gave some example. I don't know by heart. I didn't read that before. But he gave some example. But it was between fields that became progressively subfield of physics today. So he gave example, it was about chemistry and physics. But now it's like all the works dealing with this, the example that he gave, it's kind of, it's a subfield of physics. So I don't know if in the future finance will be a subfield of physics, but you know, but he didn't give example about physics and science like social science, let's say. So here there is a kind of, there is a specificity here. But he gave some example, yes. I can give you the exact reference about this and also the example if you want. Okay, so finance now. I'm talking about financial economics. And I don't want, again, I mean, I'm teaching finance. I mean, I love finance to some extent, but I don't want to be reductive, but I'm going to talk about the mainstream. You know, what you can find in the textbooks. Because this is what we teach. This is the basic. This is what all people in finance have to know. Of course, I know that you can find this literature, this specific literature, this, yes, I know. But with the vast majority of people in finance, they have to know the basic. And the basic is what will, from a philosophical point of view, will define your disciplinary matrix. I mean, everything you will see through the first degree you have. This is what Thomas Kuhn explained. You know, that's why it's very important. And I'm going to talk about this mainstream here, okay? So I know that finance is a huge literature. What I want to say is just I don't want to reduce all finance to what I'm going to say. I'm just talking from a categorical point of view. Good. Financial economics is based on econometrics in the way they are dealing with data. They use econometrics. So what does it mean? They use statistics. Okay, fair enough. They use statistics, but in a very specific way. And it's a very old story. Econometrics, it's another example. Who developed econometrics? Physicists. I mean, in the 30s, you have the name of the, I'm very bad with the names, but a lot of physicists, they began to work in economics, and they developed progressively econometrics. So econometrics would not have been developed without physicists. So another example, and I remember that I had a debate about that, the American Economic Association. I was talking about econophysics, and they told me that it's nothing new. Econometrics was there before. Econophysics is a pale copy of econometrics. This is what they told me. And then I decided to write a paper about the difference. Because econometrics and Coles Commission is very different if you check econophysics and how the context of science in the 80s and 90s due to the Santa Fe Institute. I mean, you have a lot of conceptual implications. And I mean, we were not in the same world in terms of scientific context. So I decided to write a paper in order to clarify these two different contexts. Moreover, the targets, I mean, the objectives are very different between the Coles Commission, the Santa Fe Institute, the econophysics, and the econometrics. We are not in the same world. But it looks like it's the same because they use statistics, but not in the same way. So, and how they use statistics? How they use statistics, roughly speaking, in econometrics, we don't use statistics like that in order to... we are used to saying in finance that the data will not talk by themselves. You have to have an assumption. This assumption is coming from where? Economic theory. We have to give an economic assumption. From where? A textbook. Or from a big name, or, I mean, from economics. But you will not try, so that means that you understand why we will not see the same thing. Because when we have something, we have to give a color at the beginning. And the vast majority of people, they will begin in the same way, because there is a psychological bias, a disciplinary psychological bias. That's normal. It's true for everybody, I mean, for all scientists. So, statistical methods are used in order to test economic theories. So that means that we assume in advance the economic theories we have good reasons to believe in, at least. We don't say that they are true, but a priori, but we think that we have good reasons to consider that they are true. And the statistical methods will tell us if we are right or not. But that means that we will not begin with the data like the data is there, and we will try to see what we can say about this data. It's not so data-driven. It's theoretical-driven. It's theoretically, oriented. Yeah, we start. Yes,
Just
yes,
proposal.
but that's very important. It's a very old debate here. Avelmo was, as a father of one of the father. It's a very old. So why this is a justification usually given? Because variables used by economists results from interactions among a lot of things that we cannot capture, unobservable, and without further information in general, it's impossible to infer something. So we have to start with a theoretical perspective. That's interesting, because as you can guess, we are not in the same conceptual world. So, what does it mean? That means that in terms of dealing with knowledge, in terms of doing idealization, modeling, it's very different. So, usually, again, roughly speaking, because I'm aware about a lot of things, and I'm going to talk about that now, but roughly speaking, what do we do in finance, in the mainstream, when we teach financial econometrics and these kind of things? We say that, okay, we will have two kinds of theoretical assumptions. The first one is the fact that people are perfectly rational. Okay, so this is a specific idealization regarding to the behavior of agent. And we have a kind of another idealization regarding to the dynamics of the system. That will be a kind of Gaussian. That's funny, because you could ask me, why Gaussian? For a lot of reasons. I mean, I can talk about that until tomorrow, but I could be very roughly speaking historically speaking, the Gaussian distribution was used by economists and financial economists in order to justify the scientificity of the discipline. If you check, for example, the origin of finance in the 60s, you had who were the bosses in finance in the 60s? Technical analysis. People who are just looking the evolution of the market, and they try to identify some patterns and just to inductively to say, oh, that will be the same, so I buy, I sell. That was the mainstream in finance in the 50s. Then you have Markowitz, 52, with the portfolio analysis, and then after you have Sharp and all pharma and everything in the 60s. And what was the war at that time? The war was to say, forget the visual analysis, we will focus on statistical perspective, and for that we will use Gaussian. And then you have a specific case, Mandelbrot. I know, we can talk about that if you want, but I have lovely also quotations about Mandelbrot and pharma. But anyway, Mandelbrot is a bit specific case, let's say. We can talk later about it. So Gaussian distribution from an epistemological point of view, sociological point of view, was used as a justification for the scientificity, legitimacy of the field at the beginning. That contribute to the institutionalization of finance. Thanks to that, finance became outside, progressively. If you have a PhD today in finance, it's not PhD in economics. I mean, we don't like to, even when I was students, we don't like to mix. I am in finance, I'm not in economics. I mean, it's different. And it's more and more, it was more and more the case in the 60s. And another aspect that I don't know if you know, but if you check all, I'm teaching a module that is, the title is Finance and Society. I try to explain to my students where financial knowledge, assumption, models are implementing in the reality. And what we do again, we take a lot of text coming from financial authorities and how they justify the flash crash, how they justify what kind of solution they can give to problems, crash and so on. And you know what is the word that is coming very often from a scientific point of view, what kind of scientific legitimacy they use? The Gaussian framework. And you know why the financial authorities, they love the perfect market hypothesis and the Gaussian? Because the best way to do something on the market is to do nothing. Because if the financial authorities have to take a decision on the financial market, they will maybe do something that will be good for you, but bad for you. So you will complain a lot, and that will be messy for me, the financial authorities. But if I can justify that the market is fair, so the market has a Gaussian law, so the same probability for you and for you to win or to lose, the best thing to do is to do nothing. So I have a statistical justification not to go on the market. And moreover, I will not have enemies on the market. So that's, it's very funny to see if you check in detail some text from financial authorities, how they use statistical justifications in order to say, no need to regulate this aspect. The market is fair. So that's interesting. Anyway, I don't want to talk hours about Gaussian, but the Gaussian framework is very important in finance, and this is like, we assume that it could be nice if the market would be like that, and also from a technical point of view, it's a lot of properties, as you mentioned before, that are very important. Of course, it's easy in order to characterize, you have the values very easily, you can talk easily about things. Anyway, good. This way of working from a philosophical point of view, here I'm taking the hat of the philosopher of science, is like Galilean idealization. So that means that people in finance, they are doing some practices by introducing distortion in models. They know that it's not true, simplifying the reality in order to have, a mathematically tractable solution. That's all. Okay, fair enough. If it is a Galilean idealization, you should have what philosophers of science call a de-idealization. Because you cannot have a Galilean idealization without having a de-idealization. And Galileo himself developed this kind of stuff. And we can find that in finance as well. We can find that. Regarding to the idealization of perfect rationality, you have all the prospect theory, Kahneman-Tversky, and all this, behavioral economics, behavioral finance. And you know that the prospect theory, it's a wonderful theory, because, Kahneman won the equivalent of Nobel Prize in economics. Why? Because he showed that the perfect rationality is a specific case of behavioral finance, or behavioral economics. So the perfect rationality is a specific case of people who are not rational. That's all. So that's interesting. From a Gaussian point of view, well, then I'm just talking about all these corrective models here. If I talk about Arch, Garch, E-Garch model, I know that we could mention also, yes, but there are some, here, what I had in mind when I wrote this is the fact that, this Arch model family, we have a Gaussian trend, and then we have variation. And this variation, we will try to capture these variations with another statistical distribution in order to define them. So that means that we have a kind of unconditional distribution, that is the Gaussian, and a conditional one, that is the variation that we have to describe in a different way, that could be no Gaussian. So this is the one I had in mind. But you could mention, yeah, but what about jump process and all this literature? But I didn't deal with that here, because in econometrics, Arch models are much more, as far as I know, to my knowledge, much more mainstream than all these categories of models like jump, pure jump, all these kind of models that are, okay, we deal with that, but it's not so mainstream. Arch is totally mainstream in finance. So, okay, fair enough. So that means that from a philosophical point of view, we could say that economists are using a kind of Galilean idealization. So, okay, keep that in mind. I will make a table at the end in order to compare the two, okay? But keep in mind this Galilean idealization, and on the side it was minimalist idealization, if you remember, okay? So, okay, good. Now, I would like to talk about the methodology they use in finance. As you know, we use statistics, but in a specific way. So, and this, I think, is very nice. Andre is a very big name in econometrics. The three golden rules of econometrics are test, test, and test. I think it's beautiful. It's very easy to say that. Why? Because, well, because it's rigorous, because it's important to deal with data, blah, 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 but to be scientific. That's the point. Test, test, and test. So we have a panoply of statistical tests aiming at providing a quantitative validation of an a priori knowledge. What kind of a priori knowledge? The kind of economic assumption you need in order to deal with the data that are there. So you have data, you have a priori knowledge, and you have good reasons to believe that it's true, because the economic theory tells you that. It's an a priori on the world, okay? And then you will use tests, statistical tests, in order to validate it or not. So that's the point. What kind of tests? A lot of tests, and you can find billions of tests, but all of them have a meaning in the Gaussian world. I didn't mention, there's a paper, an interesting paper also on that in econometrics. It's a critics, an econometrics review. It's a very good paper about the statistical test. I should have mentioned. I will send you, what I will do, I will send you references about what, all the references I mentioned already. I think it would be better for you to have that. And it's a paper about the fact that all statistical tests in econometrics make sense in a Gaussian or implicit Gaussian framework. So even when they deal with extreme value, the concept of extreme value has a meaning regarding to what does it mean to be not extreme. I mean, in a Gaussian perspective, but Gaussian perspective means a lot of things. Included from a rational perspective. I mean, you know, when I was talking about it, you could have mentioned to me, there's a link between these two, of course. No, not this one, but yes, I mean, if we can have a link between Gaussian distribution and perfect rationality, yes, of course. Read again Markovitsky. Everything is there. I mean, this is the axiomatization. You need this one in order to have this one. And this one is the expected rationality, utility, you know, the expected utility rationality theory from Morgenstern, von Neumann and Morgenstern theory. So everything is in Markowitz. Markowitz, beautiful what he did. He's beautiful, it was in 52, I mean, it's clever, but we need one in order to have the other one. So why, that makes sense to make statistical tests on the Gaussian and try to keep it to some extent. So everything is defined regarding to the Gaussianity. Everything, you know, we are in this kind of Gaussian world, implicitly or not. Even when you are not in, you have to explain why you are not in. So that's, even if you want to, I guess, you know, when you want to publish a paper in mainstream, you have to, good luck if you don't, I mean, in econometrics, good luck if you don't mention, if you're able not to mention the word Gaussian in your paper. I mean, I think it's a good challenge, sociological exercise. Try to publish a paper, a technical paper in a financial mainstream without mentioning Gaussian, the word one time. I think you will never be able to. I think I should try. I mean, it's a good idea. I should try to see if it's possible, but I think it's not possible, to be honest. So, anyway, but so you got the point. In financial economics, we need an a priori knowledge. We have data there. We need an economic assumption, and then we will use a lot of tests that are extremely complex and sometimes, you know, an abuse of statistical tests. I found a good paper also, Kreuzen-Mackup, I think the guy, he wrote a paper about some papers in econometrics, I mean financial econometrics, in which you have more statistical tests than data. So, and he was asking, so what about the data there? They forgot the data. Yeah, I mean that's interesting. I mean, I will put that as well. In this paper, you have more statistical tests than data. And that's interesting, because then he said we have a use and abuse of statistical tests in financial economics. Why? Because we have to justify this economic assumption. And basically when we read, you know, Journal of Finance or something like that, you have data, economic assumption, a lot of statistical tests, and then, oh, it is significant. Okay, so we are happy. We can believe that the economic assumptions are true, statistically speaking, because it is significant. Yes, and that's all, they stop there. And you know, the only philosopher that you can find in Econometrica and Journal of Finance, that are the two Bible of the financial mainstream, and Journal of Financial Economics as well, is Popper. Popper is the only philosopher they mention. And Popper is the only philosopher that economists know. Why? Because we know that we have to test. And who was the philosopher who developed the concept, I mean the importance of test, is Popper, falsificationism. However, they don't really implement Popper in line with Popper. It says that, well, people in economics, they are economists, they are not philosophers, so they will not read Popper. But here I just use a quotation, like a very simple reasoning of the Popperian way of thinking. Popper, according to Popper, you cannot verify a theory. Never. Never, never, never. He is against verificationism. It was a war against verificationism. It's falsificationism. So here, financial economists, they are using Popper more in verificationism. way than falsificationism. What does it mean? That means that here's the process. Scientific, normally you have a problem, P1. This is from Popper. It's like a very good summary, I think, of his thought. You have a problem, okay, good, P1. Then you try to give a solution. What kind of solution? This is depending on the discipline. Tentative theory. You put what you want in, but it's like kind of characterization. Okay, TT, good. Then must be criticized and tested. You test here. Good. Then why you have to test it? In order to, to eliminate the error, the stuff that you cannot explain and so on. And normally, you must renew the process. You have to continue and you have to develop further the test, more and more. The most important is not the economic assumption that you can, for which you will find a statistical significance. The most important is to what extent you will improve the statistical test in the future. To what extent everything you have show that it is statistically significant today, to what extent tomorrow it will not be anymore. Or to what extent you will challenge that. Maybe it will be, but you have to challenge it again and again and again. This is Popper. So in financial economics, they stop here. So they say we have a problem, we have a theory, we have the test, we can explain something, so it's okay. And then they will not necessarily go further in the test. So Popper, that's interesting because Popper himself contributed to this way of thinking in financial economics because he said, I think that econometrics and financial economics, now with the number of data they have, they will be able to be more and more like physics. I mean, Popper wrote that. So he contributed to that, but it was in, he wrote that in the 60s, I think. So it looks like 40, 50 years later, I'm not sure that they are implementing the process in a Popperian way. I'm not criticizing financial economists. I mean, they don't have to. They are not philosophers of science. I'm just using this, glasses of philosopher of science to say that stop to use Popper to say that it is scientific. It's not Popperian. That's all. I'm not saying that what you are doing is wrong or what. We just say that it's not Popperian. That's all. So that's an interesting point because it's a naive interpretation of Popper. So okay, you got the point. I hope between this statistical econophysics, finance economics. So as you can see, understand, we are in the two different worlds here. And then in philosophy of science, we use constructs in order to talk about the way in which people perceive and interpret the world. So we are in two different conceptual worlds. And constructs are very important because these constructs will give you the rules of interpretation about the world. You think and you will see something in the nature in a specific way because you are a physicist. An economist will see it in a different way. That's normal. There is nothing wrong with that. But we have to integrate that to take into account in a possible dialogue between the two disciplines. And it looks like because we are using the same data and the same phenomena and the same models, the same statistics or agent-based modeling, we should see the same. No. Because of the constructs. Because of all this implicit knowledge behind, all this implicit way of developing knowledge that I was explaining here with minimalist idealization versus Galilean idealization, these kind of things. So it's very important because communities, they have different language. So, and I would like to, here it's kind of, summary, I don't remember, no, it's the last one, but I will give you a bit more information about here. So here is a kind of summary. You have statistical econophysics, again, this is the one I was focusing on today, and financial economics, again, I'm talking about the mainstream, using the econometric way of modeling. The justification is based on the Duhamian analogy. I explained you, this extension from outside to come back, and blah, blah, blah. Popperian rhetoric, I just talked about that before. Idealization, minimalist, this way of thinking, this way of implementing an asymptotic reasoning in order to identify something. Galilean idealization, how to have a priori knowledge about the world that we can change a bit in a perfect rationality, Gaussian in economics. Argumentation, asymptotic, I mentioned that. Additional, I didn't mention that, but in economics, you know, usually it's a very micro-oriented field. We define one item, and we will say everybody will do like the same. You will do the sum. You know, the room is just the sum of the component, that's all. But it's not the same with an asymptotic reasoning. You could have, the results could be surprising. Could be a bit different than the simple addition of all elements. In physics, you are aware about it, you know that because you deal with, you have some, you know, the self-criticality, you have billions of ways of characterizing this, the fact that the system can be more or different, at least, than the mere sum of the components. But it's not really used that in economics. It's just the addition. You have this guy and you make the addition. All of them will be like that, and the addition will be the system. So it's a bit different way of dealing with aggregation. With, actually, I should have used here aggregation instead of argumentation. Anyway, validation. This is also interesting. I didn't really go here, but statistical test, I mentioned that. The importance of statistical test for economists. Visual test. Why I mentioned that for econophysics? I had power law in mind. That's why I mentioned that. I was a bit quick to write that, but let's continue the reasoning. Why I did that? I've read a lot of articles in statistical econophysics. And what they do, and it's very interesting, what they do, they say that, okay, we have the data, we have this characterization, and we can see the power law. And the we can see can take different forms. You can see just visually, you can see that, you know, log, blah, blah. Some people, they say that, yeah, the computer tell me that, you know. But at least since we have, I don't talk about that, but the importance of computers in the development of statistical econophysics is huge. I mean, I could talk about that a lot, but they say that the computer give me the feeling that it's true to consider this as a power law. But it's visually. I mean, Marcel wrote also some test about, yeah, but is it really the power law at the end? It's not really the power law. I mean, Marcel also wrote some stuff. But I didn't find a lot of specific tests to see, is it really the case, or is it an exponential law in a specific way? I mean, it's not clear. And you have this game, Le Baron, I mean, that he wrote some paper saying that, really, is it a power law? I can show you that an exponential law, you will see the same. Actually, is it the power law or exponential law? You will see a power law, and I will see an exponential law. And who is, you know? So, you know, you can find some articles, critical articles on that. But actually, it's quite interesting to see that in physics they say we can see. In financial economics, it's impossible. This is the kind of sentence they stop to listen to. We never see something. We always, statistically, we give a statistical significance to that, but we never see. And why? It's related to the history of finance. Financial economics emerged in the 60s by fighting against technical analysis. They were based, all this technical analysis was based on visual tests. So they keep it. And when you are in finance, and you do finance, you learn, you know, the two verses. I mean, at 30 years, you learn something. People who are doing technical analysis, they are doing astrology. And I mean, this is written in the textbook. That, you know, this technical analysis, I mean, you know, they are lovely, it's a bit astrology, they are saying, oh, look, you can see this, oh, we can find it there. But that depends, of course, on the sample, that depends on a lot of things. So, visual tests in finance, no way. I mean, they are extremely critical. We never see something. So, that's interesting because this is very common. When, I mean, I talk with people in finance in the mainstream and they say, yeah, but they say we can see. What you can see? I see what I want. So that's an interesting point. And then a priori knowledge, well, I don't want to say that only people in finance have an a priori knowledge. All of us we have. I mean, because we are in a discipline. I mean, it's normal. All of us, we have a disciplinary bias. When we see the world, we are physicists, we are philosophers, we are economists, we see something because we have a background. So people in econophysics, in statistical econophysics, they will see a complex system. And then complex system means a lot of things for them. So they have a kind of a priori knowledge as well. I mean, a priori perspective. I mean, in finance, like, it's not a complex system. It's just a system composed by a lot of people, and we can define it individually. Then we will do the aggregation, and then we will have normally, hopefully, a Gaussian world. And if not, we will capture the the error in a specific way. This is what they will do, roughly speaking. So now, here I just identify all aspects for which we don't have a dialogue. Is it possible to have a dialogue between the two fields? I think so, honestly, I think so. But it's a very big question. I think so. First of all, I mean, if we take just here, if we just focus on the power aspect, the visual test and so on, this is what I was mentioning to you with when I talked with Mitzenmacher, was saying that we don't have strong statistical tests outside of the Gaussian framework in order to capture something, I mean, to have a significance of the power law, to test the significance. So, and he said that unfortunately nobody is developing that. It's more statistical, it's research in statistics more than something else. But it's true, he gave me some example also in medical science, in biology. It's not true for econophysics. This problem is true for all people using power laws. But there is a room there, because people in finance would be very happy to hear this statistical significance. Well, they would have to do an effort as well to think outside of their Gaussian world, but they are not bad person. I think they would be able to do it, but at least that would be the same kind of language they are using to implement in their way of developing knowledge. So there are some possibilities, for sure. But here I just wanted to, the title was Impossible Dialogue, so it was just focusing on the difference and from an epistemological point of view. But we can talk further if you want about, the possible development in the future. Okay, so I think I am at the end. Thank you very much for your attention. I hope it was not too epistemological. And if you have any questions, I'm very happy to reply. Thank you.
Thank you very much for this beautiful seminar with a lot of interesting concepts and views. Are there questions? Yes?
Yeah, first of all, first of all, thank you for the seminar, because as a previous physicist
We are still physicists.
You will stay.
Formally, I'm still a physicist.
You will stay.
Yeah, and econophysics or whatever. What I miss sometimes is like a discussion on how we build our knowledge, and so basically a discussion about the epistemology of physics, of econophysics, and whatever. So I really appreciate that, because it's basically focusing on the building bricks of theory. That's really nice. And my idea about the possibility of a dialogue between the two fields are based on the fact that, as you clearly put, basically econophysics is more about this, finding sort of maximum common denominator in different realization of a process. So basically, we look for patterns, macro patterns in data. While, the Galilean idealization of economics, financial economics, is more about basically starting from a theoretical assumption that makes sense and then testing it and see what happens. So you mentioned, Gaussianity and rationality and this kind of assumption in economics, but I think that the point is not only that there are many aspects in which we see that our statistical tests say that that are not really the best assumptions, but now there is also some sort of source of knowledge which is external both to physics and economics that says that, for example, we know that the Homo economicus assumption is not really so good because, for example, we know that we are not really efficient in processing information and we do not always take the best choice that sort of maximize our profit. So my idea is that if it is possible that a shift in economics, as for example Popper suggests, a shift in economics from this kind of assumption of Homo economicus, Gaussianity, and this thing to something which is more related to, I don't know, recent findings in cognitive science or behavioral psychology, could somehow make the perspective of the final results of econophysics and economics closer sometimes.
Well, I think you are emphasizing two interesting points. The first point is that financial economists, they are aware about the fact that rational agent is not realistic. And they could reply you in a very sarcastic way. Do you think that, you as a physicist know that a lot of description that you are giving from the world is a caricature of this world? You know what I mean? So all of us, we know that in science. This is the way of doing science. However, what you mentioned is important in the sense that that's why we have the behavioral finance and prospect theory, explaining that all of us, we have a lot of psychological biases, like anchors, we all the time. We don't want to, every time we think about something, we always think about a specific reference point. We know that we are not afraid about risk, but we are afraid about losses. I mean, because risk, the vast majority of people, they are not able to define it. What is risk? I don't know. But if I lose money, I know what I'm losing. So the aversion should not be for the risk, but for the losses. So all these aspects, they know that. However, they will say that, yeah, but do we have to go in details in order to capture the essence of the phenomena? You would say that this essence will not be the same for you than for them. But what you mentioned there is a very important point. I think a good future path between econophysics and finance would be behavioral finance and econophysics. Because then you have some aspects, some very interesting aspects. I think I found one paper about behavioral finance and econophysics. That would be an extremely, I think, personally, I mean, after having read a lot of stuff, I think that would be very interesting. I mean, not just putting behavioral finance and econophysics and saying that, look, we have good reasons to believe in this or this. Not that, but really try to develop something, that would be, I think, a very, very interesting way of doing research. And I think implicitly this is what you emphasize there.